Bueno, muchas gracias a todas y todos por estar presentes el día de hoy en esta tercera sesión de las jornadas de usuarios de Ansys que estamos organizando en la UPM este año. Es un evento, bueno, tengo que agradecer una vez más a Fernando Pescador, al vicerrector de Servicios Digitales, a José Ignacio Pastor de la Escuela de Caminos, y todo el equipo de audiovisuales que nos ha gestionado todo para tener un aula increíble que es esa. Y como ya he dicho, creo que hay gente que está ahí desde la primera sesión, entonces, una vez más, las mismas bromas que en las dos sesiones anteriores, entonces, pero es un gran placer, un gran honor estar ahí, estar aquí en la UPM. Yo vengo de Brasil, entonces me presentaré ahora con esta diapositiva. Bueno, la foto es antigua, pero los datos son verdaderos. Soy de Brasil, por eso también ya pido disculpas por el portuñol, que suele pasar. Soy ingeniero de materiales y ya desde el trabajo fin de grado he hecho un poco de investigación sobre la enseñanza, el currículum de ingeniería, en aquel caso ingeniería de materiales, pero eso después lo profundicé con una investigación de 2 años y medio en una maestría en Brasil sobre los modelos de enseñanza de ingeniería entre Brasil y otras partes del mundo. Luego hice un doctorado en Francia, volviendo un poco al tema de materiales y en este caso de industriales con diseño de producto y economía circular, que era un tema ya un poco nuevo en aquel tiempo, en 2013 cuando he empezado. Y después de la tesis me he ido a Granta Design, que era una empresa fundada por el profesor Mike Ashby de la Universidad de Cambridge, del Departamento de Ingeniería Mecánica en Cambridge, una empresa de desarrollo de un programa, de programas con bases de datos y herramientas de selección de materiales, y yo estaba dentro del equipo académico, trabajando con las universidades, parcerías, colaboraciones, relaciones institucionales y en muchas partes del mundo. Y luego en 2019 Ansys ha adquirido Granta y nuestro equipo académico se ha convertido en un equipo académico dentro de Ansys. Y estamos ya con unas 20 y tantas personas intentando estructurar una oferta y un programa académico que muy parecido con el modelo que teníamos en Granta Design, sea más que solo venta de licencias. Entonces eso es un poco el mensaje que yo voy a intentar transmitir el día de hoy, pero no estoy solo. Entonces este es más o menos el programa. Voy a presentarles algunas diapositivas hablando del programa académico de Ansys. Creo que tendremos más tiempo al final porque como pueden ver, a las 11 y poco hay ponencias de usuarios, pero no sé, no he recibido ponencias. Hemos intentado organizarlo y aunque, no sé, si alguien ahí tiene alguna ponencia para presentar su trabajo con Ansys, con simulación, con otros programas, con mucho placer, porque la idea es compartir experiencias de usuarios. Pero si no lo tienen, yo puedo después mover alguna cosa y hablar de un poco más de recursos o de posibilidades que tenemos con el programa académico y luego, bueno, muy flexible este programa. Y la idea es que terminemos con una discusión, una mesa redonda, a las 10, como he comentado, y entonces me me quedaré atento porque hablo mucho y para que no nos retrasemos porque a las 10 se conecta mi compañero Sebastián que nos va a presentar las novedades y yo imagino sobre todo de Ansys Mecánica, que es el programa de estructuras más fundamental dentro del paquete Ansys que tiene ahora, bueno, que ya tenía, pero que tiene ahora centralizada el vicerrectorado. Y ya, tendremos un coffee break para hacer una pausa también y podemos ir a la cafetería ahí que está en este piso y ya, no sé si hay alguna duda, pregunta, inquietud en este momento o ya una propuesta de ponencia, ¿no? Eso ya sabía que iba a ser un poco difícil. Ayer también ha pasado un poco lo mismo. Bueno, les presento en pocos minutos algunas cosas del programa académico. Una duda, yo veo que hay gente que estaba ahí ya en algunas sesiones de ayer, pero hay gente también que ha asistido a la reunión que hicimos con el vicerrectorado cuando celebramos finalmente que habíamos firmado el contrato para explicar un poco lo que estaba incluso dentro del paquete, los recursos. Hicimos una reunión creo en septiembre en línea, algo así. ¿Alguien ha participado? No. Entonces, qué bien. Es decir que todo lo que voy a presentar hoy es novedad. Bueno. Entonces quizás puedo empezar por la parte que había dejado para el final y esa es la parte más interesante que dejo para después del coffee break. Para que nos retrasemos porque a las 10 se conecta mi compañero Sebastián que nos va a presentar las novedades y yo imagino sobre todo de Ansys Mecánica, que es el programa de estructuras más... Empezamos con algunas cifras dentro del paquete Ansys porque ahora seguro que están desactualizadas y que no significan nada, pero es muy impactante. Entonces, el programa académico, eso no tiene nada que ver conmigo, con lo que estamos estructurando ahora. Es un movimiento que Ansys ya ha creado hace un par de años, bueno, hace ya muchos años con las universidades que siempre han utilizado los recursos de Ansys, pero desde un par de años hemos creado más de 200 cursos de innovación y eso les comentaré un poco más detenidamente. Hay muchos usuarios de estos cursos porque son gratuitos en línea, es como el Netflix de la simulación. Tenemos las licencias Student, entonces eso también son licencias gratuitas que todos los estudiantes pueden descargar en cualquier parte del mundo. También patrocinamos equipos de estudiantes, equipos de diseño para competiciones de estudiantes y tenemos un foro donde cualquiera puede irse y hacer preguntas y recibir respuestas de la comunidad y también de nuestros expertos. ¿Ok? Pero eso no es todo, y no es suficiente. Es verdad que tenemos buen software, no somos los únicos y por eso tampoco, bueno, hay las cuestiones técnicas que va a presentar Sebastián, pero mi discusión no es en términos de capacidad técnica del software, porque yo solo puedo hablar del software de materiales también, no tengo una comprensión o conocimiento de todo el paquete. Para mí lo que interesa construir en conjunto con los parceros académicos que tenemos son recursos, son recursos docentes, recursos de investigación, son parcerías, son colaboraciones para ayudar más allá de una licencia técnica, porque eso también son cosas que manejan los usuarios mejor que yo, mejor que muchos expertos dentro de Ansys. Más allá de eso, es ayudar con la parte de, bueno, cómo publicar más, cómo involucrar más a los estudiantes, cómo tener contenido nuevo. Cómo cambiar un currículum, cómo cambiar una carrera, una asignatura. Esas son cosas que estamos pensando todo el rato y tenemos gente dedicada dentro del programa académico. No somos cientos, no somos miles, pero ya tenemos gente ya con estudio y con investigación para intentar ayudar y traer este tipo de soporte a la comunidad de profesores e investigadores. Estos son algunos de los pilares que tenemos dentro del programa académico. Entonces, hay una voluntad de incluir simulación en las carreras, no solo porque es importante quizás para la empleabilidad, pero también porque es un soporte interesante para visualizar fundamentos, nociones, conceptos de física, de la naturaleza, y creemos mucho en eso. Y entonces estamos desarrollando este tipo de contenido. También tenemos los patrocinios de los equipos de estudiantes porque creemos mucho en ello, porque son motores dentro de las universidades, son muy bien vistos también por las empresas que son nuestros clientes. Entonces ayudamos mucho para que ellos tengan éxito en las competiciones. Creemos mucho también en el aprendizaje activo, entonces en la aplicación de la simulación en proyectos de fin de grado, fin de máster, integrativos, con muchos programas, pero muchas disciplinas, muchas asignaturas que convergen en estos proyectos. La parte de investigación, y eso como comenté, es algo que podemos traer soporte técnico o alguna cosa de soporte también, de colaboraciones. Trabajamos con investigación y desarrollo en algunos proyectos colaborativos también. Ahora tenemos no solo parcería para proyectos como de investigación colaborativa, pero también para desarrollo de currículum, para cambios docentes. Entonces eso también podemos ayudar. Y bueno, al final el objetivo de todos en la universidad y en nuestro programa académico es asegurarse que los estudiantes estén preparados para cambiar el mundo. Entonces, para cambiar sus vidas con un buen empleo, con una buena carrera, pero también para hacer las transformaciones todas que necesitamos en los próximos años. Bueno, como comentaba, hay algunos motores de investigación que estamos trabajando internamente y la voluntad es trabajar también con nuestros colaboradores dentro del programa académico para mejorar el impacto de la investigación que se hace. Igual, otros criterios, pero también importantes en la parte de docencia que estamos también desarrollando en conjunto con los profesores. Que es como, bueno, mejorar esta cosa, como involucrar alumnos, como traer nuevas acreditaciones, trabajar en términos de empleabilidad y bueno, mejorar todo el ecosistema.
Muchos programas, pero muchas disciplinas, muchas asignaturas.
Ya, bueno, para eso, eso les voy a comentar de manera más detenida después. A ver cuánto tiempo me queda.
La parte de investigación, y eso como comenté, es algo que
creo que ha llegado Sebastián.
Soporte técnico.
Tenemos webinarios, pero bueno, me voy directamente a los recursos. Eso
investigación y desarrollo en algunos proyectos colaborativos.
Ahí está. Tenemos recursos docentes.
Ahora tenemos,
entonces, ayer tuvimos la sesión de materiales donde estaba hablando, por ejemplo, del software Ansys Granta EduPac, que tiene el software, pero también venía desde siempre con cientos de recursos docentes. Y eso también ayuda mucho a tener ideas, a utilizar casos prácticos para discusiones en clase. Y la idea dentro de, bueno, eso aún está en la página de Ansys, pero creo que se va a mover en el portal de innovación que hemos creado, que les comentaré más adelante, pero hay un montón de contenido para diseño, selección de materiales y proyectos mecánicos, porque eso viene de la empresa Granta Design, entonces de la metodología del profesor Ashby y todo mucho contenido, ya más de 200 documentos, pero estamos creando también, y eso está desactualizado, porque ahora sí van en la parte de
la investigación que se hace, igual la misma
de producto, hay también el Ansys Discovery y el Ansys Mecánica. Entonces, estamos colaborando con profesores y también hago una convocatoria si hay profesores que quieren participar y colaborar con nosotros para desarrollar este tipo de contenido para la comunidad. Tenemos mucho que desarrollar en conjunto, porque también los educadores están todo el rato haciendo sus propias presentaciones y trabajando con simulación, elementos finitos para mostrar cosas a los alumnos. Entonces eso también hace parte de lo que estamos desarrollando con un modelo del profesor Ashby y de Granta, que es un modelo de aprendizaje activo con muchos estudios de caso y presentaciones, pero también compartiendo archivos del proyecto y facilitando, trayendo soporte para que sea lo más cómodo posible utilizar el software, pero también enseñar temas de la actualidad, sostenibilidad o cálculos estructurales o qué sé. Los cursos de innovación, entonces es cursos.ansys.com. Son más de 200 estructurados por física. Después podemos abrir la página y les muestro un poco cómo están. Pero muchos profesores los utilizan para que los alumnos los miren antes de venir a clase. Entonces, si hay un tema que va a ser desarrollado en una clase, antes de ella hay ya quizás algunos videos cortos en un formato muy interesante ya para la nueva generación, y eso sirve para preparar algo. Y hay cosas solo de ciencia, entonces de cuestiones fundamentales de estructuras, por ejemplo, y también hay videos que muestran cosas de producto, aspectos o más prácticos de la utilización de los programas. Entonces hay un poco de los dos.
Hago una convocatoria
para parte de materiales, eso es nuevo, entonces eso tenía de la presentación de ayer. Entonces estamos siempre creando contenido, y entonces para parte de materiales tenemos ahora nuevos cursos de selección de materiales. Para parte de estructuras no tengo ni idea de cuáles son las cosas nuevas, pero como tengo más de 200 en estructuras, no sé, 70 cursos, algo así. Entonces hay mucha cosa, y la retroalimentación que tenemos es que es interesante, vale la pena, y en algunos casos también facilita mucho. Tenemos el forum, como he comentado, y también todos los recursos del Resource Center que están aún en la página. Entonces, todas las grabaciones de webinarios, papers,
facilitando.
Hay mucho contenido, estudio del caso, y está, como tenemos mucho software, es posible hacer filtraje por producto, por aplicación. Entonces, hay muchos verticales que están ahí, como automoción
los cursos de innovación
automotivo, la parte de energía, aeroespacial. Entonces todo está ahí ya organizado.
Cómo están, pero
tenemos también
muchos profesores
un
los alumnos los miren antes
una serie de webinarios
Entonces, si hay un tema
que
va
hacemos
desarrollar
ahora dedicada a la
clase,
comunidad académica.
antes de ella,
Entonces,
hay quizás algunos videos
hay
o-
cosas de todas las físicas que tenemos este año ya, creo que fueron 12. Tenemos uno la próxima semana sobre selección de materiales,
para preparar
cómo enseñar la selección de materiales,
solo de
pero
ciencia,
hemos tenido uno de manufactura aditiva, de transferencia de calor,
de estructura.
de diseño de antenas,
También hay
un estudio de caso multidisciplinario de diseño de drones, donde teníamos toda la cadena desde el análisis del material, selección de material, cálculo estructural, optimización topológica, la parte de fluidos y la parte térmica. Solo faltaba la comunicación con antenas, pero eso es porque no teníamos el experto. Pero lo hicimos y eso también creo que va a ser publicado como recurso docente. Entonces hay la grabación en la página de los webinarios, donde están recogidos todos y tenemos el programa de los próximos, pero también tendremos el documento, ¿no? El PDF para poder trabajar reproducir el proyecto o, no sé, discutir en clase del proyecto con los alumnos.
Las grabaciones de webinarios.
Y bueno, también hacemos este tipo de evento como el del día de hoy, jornadas de usuarios. Me llaman para hablar de materiales y sostenibilidad a los alumnos, eso también puedo hacer, o presentar la simulación, los beneficios de la simulación a los alumnos. También llaman a nuestros otros expertos para hablar de otros temas, hacemos talleres, todo tipo de cosas. Claro que el tiempo es el limitante, pero estamos intentando cuánto podemos estar ahí al contacto de nuestros usuarios.
Dedicada a
como sé que hay un poco de interacción entre estructuras y materiales, si hay profesores que también están involucrados con temas de enseñanza de materiales, este es un evento muy, muy interesante que tenemos, que se organiza todos los años. Bueno, los dos de la pandemia no, pero en Cambridge es el simposio de enseñanza de materiales y hay una comunidad muy, muy bonita alrededor del profesor Ashby. También viene el profesor Callister y entonces la llamada de Abstracts está abierta hasta inicio de diciembre y para pósters hasta enero. Y como muchos eventos de enseñanza, es un evento más de compartir, no hay tanto la cuestión de los egos, de los investigadores que están peleando para tener la publicación, eso no, eso es para compartir, difundir ideas y entonces es muy interesante y merece la pena bueno, si tienen una ponencia que tiene algo que ver con enseñanza de materiales,
el proyecto
es un consejo que dejo ahí.
Discutir en clase.
Bueno, como he comentado, tenemos muchos recursos para los estudiantes para que puedan descargar y utilizar en sus propios ordenadores, trabajar desde su casa y traer los proyectos para desarrollar con las licencias de la UPM que no tienen los límites de las licencias Student. Entonces, tenemos también para quien hace la parte más de explícita. Ahora hay una versión de Student del ESTRUCTURAS también.
No, egal, ich wollte so kleine Flecken
Todo
machen.
tipo de cosas. Claro que
Sorry.
el tiempo es el
Sebastian?
limitante, pero estamos intentando.
Sebastian?
Yes, I'm here, sorry. Yes, I'm here.
Al contacto de.
Thank you. Can you hear us?
Yes, my wife was just dropping in. I forget to mute and she told me if I can understand Spanish. And I said to her, I will make my own English because my Spanish is not so good.
Yeah, I asked, and we don't understand German, so.
Okay, we can meet in the middle. We make French today, right?
No, let's do English. I think English.
Yeah, of course, was a joke. Was not serious. Of course, English.
Sebastian, I will stop now, no problem, because I know you're kind of stretched for time, and I want to give you as much time as possible. Let me just go to the next room. Can you try to share your screen? Because I don't think you have the rights. I need to go to the room behind this one, where we have the back room with all the technical stuff, and I can try to make you a host so that you can share your screen. Can you try?
Okay. So, can you see it?
Yes, excellent. So I don't have to do anything.
Working. Oh, this is unexpected, right? It's good. It's good. It's working.
So, Sebastian, the floor is yours. I've already told them that you are our expert. We have microphones here so that you can hear us. So I will pass them along if at any point you open for questions. And that's it. The floor is yours.
Okay, thank you. So then let's have a start, and let's see how much we can see today. So you can see some numbers here, and just to explain those numbers in front of our scope is that we have 262 slides for mechanical, 114 slides for Alice Steiner, and 21 slides for beta only for 2020 R1. This is quite a challenge to present it in 1 hour, to be honest. And so if we look at this kind of iceberg, so I only show you some selected slides, and you can have all those slides after the meeting. So that's not a problem to share those slides for you for more details at the end. So I will present 207 slides in 1 hour. I make it quick, and yeah, sorry if it's a little bit like a movie today. I try to stop at the most important highlight points to bring this to your awareness. And at the end, the 3 stands then for what are your takeaways from the meeting? What information do you need also after the meeting? And how to proceed. So what we could do, if there are some groups who wants to know more about certain areas, then please reach out to one of us, and then we can, let's say, have a more focused session, maybe half an hour or an hour on a specific topic, what it's interesting for only a few people of you. So it's quite a broad overview. So I try to touch on all of those areas here, so mechanical external models, meshing, post-processing composites, and so on. And just to bring you to your awareness what it's worth looking at, and where some big improvements have been done in this version. And if you're interested, you can also get all kind of slides between your actual version and the version you are using then at the UPM. So for mechanical, one of those most interesting and new things is we can use widget transformation on external data. So let's imagine you have certain external models, they are not in place, and then you can directly type in the correct coordinates and bring them to the right position for your overall assembly. Then we have worked on the context shell element scoping, so we can have a different kind of visualization, seeing those elements, and then also it's having it easier to assign them. And always a good way is to use the named selection for that. So that's a good practice, I think. So then what is really a big improvement is the beam-to-beam contact model for contacts. So it's easier to really model beam-like structures and get them into contact. So you can see we have this exclude crossing beams, only crossing beams, or all. So you can decide what works best for you at your model. What is another big improvement from my perspective is the RSM file manager. So we can decide what kind of data we want to bring back from the cluster. So it's not everything, not all gigabytes of data will come over and come across, only those who are interesting for you post-processing. Then an end release scoping for connections. So this wasn't possible in the past, but now you can define end releases if you need them. We added some seam welds, so we can define seam welds on a meshing basis, and we can also have better overviews over seam welds. So if you want to bring those into your simulation, then you're very welcome to do that, and we have new capabilities. Please ping me simply if you need more about welding, seam welds. It's a topic on itself, and we can have an in-depth discussion about that. At geometry imports, we have done a lot of things to improve this kind of import things, and as mentioned, also having rigid transformation. So you could copy the same part twice and simply use rigid transformation in having a duplicate of this kind of model, if you like. And the pro tip is you can directly import this also directly inside mechanical now, geometry import, and then you can import your models directly at this place. Then we worked a bit on the kind of finding bodies in the tree, as you can see. So it's easier to click on a geometry, and then you also can go to the corresponding bodies in the tree. And as always, it's a good idea to have a good naming for your parts, and then you can also use the search engine. If you look at the outline name and search outline, then you can also type in the name for your part, and then you will get a filtered list of all items in your model. Resource prediction enhancement, maybe this is one of the big ones for me, because Ansys is now telling me if I'm enabling the beta options, how much resources are expected from the simulation run. And so you can then tweak your model with respect to the number of mesh elements to fit your computational requirements. The NLAD, this is the remeshing of parts to meet also large deformations. We can now apply this to the initial mesh, if you like. So this is something what was requested, and now it's available. And here you can see how this looks like. So on the left-hand side, you can see apply to initial mesh set to yes, so the loading is applied, and on the right-hand side, it's not applied. We did a lot of things with fracture mechanics. This is quite an interesting field. It's also worth 1 or 2 webinars possibly. I just wanted to bring it to your attention that we have a lot of fracture mechanics now and improvements in this regard. The bolt tool. So we have now a hole detection and connection creation for bolts. So it's all about automation, that it's easier to create bolt connections for you. So try it out, and as said, reach out if there's anything where I can help with, and if it's not working for you. It's more robust than the object generator. This is why we introduced it. Direction probe wizard, it's the same idea, yeah. So we can use this kind of wizard also for having this reaction probe instead of clicking it several times in the tree. For the external model, so this is just external models can be used for many things. I also know that you possibly don't use a lot of Abacus, possibly nothing at all. Just to get it to your attention, Abacus is now able to bring in to mechanical to run comparisons if needed, and we worked heavily on getting all kind of information from Abacus into our solver directly. So if it runs as designed, you load the model directly, you press the solve button, and then you have the setup from Abacus, and then you can run it with our tools to improve it. Okay, meshing. You see, it's a long list what we can do. let's jump in and bring in the highlights. Shell meshing, we did a lot of improvements to reduce triangle reduction and to improve the quality of it. Of course, if you're not used it yet, it's called the batch connection. You find it in shell and solid and beam only setups. Then you can use this kind of batch connection for better, faster, reliable shell meshing. Please make a note for yourself, and if you want, reach out to me. I have also material corresponding to that. So, and here you can see the effect of the tree reduction with non-conservative and aggressive. Weld meshing. With the weld meshing, we have different kind of worksheets just to check if they're all sane and working. And weld meshing improvements for graphics. I mean, if you never used it in older versions, you will not notice it, but there is some kind of improvements here. And here you can see this kind of weld meshing. The idea is to connect it directly to the mesh. So we don't need to define geometries for our welds. We can directly say we have two line elements, and between those line elements, he will then create this kind of weld. And this kind of a preview of the welds. Okay, there's no video. And again, some kind of weld meshing criteria where we can add, remove things, and add some number of layers and so on. Give it a try, and if you run into something, please let me know. And here's some kind of examples of this coincident welds and the layering. So what's quite interesting is this kind of pool of line coatings. So that's the setup for it. We have a 2D mesh, and now we can say, let's pull it. So that's all. It's an extrusion of the mesh in a pull direction. So we don't need to create a 3D model and try our multi-zone or thin our sweep algorithm for creating a mesh. We can use this 2D mesh, and then we can pull it. Space-time meshing, it's another field you find directly in space-time meshing. This capability, sometimes it's simply not activated by you, but the tab is not visible. In that sense, look in the space-time options, and then otherwise give me simply a sign. I'm happy to help you to find this kind of option. And the idea is we need hexa meshes for Alice Steiner for the time step width. And so space-time meshing can help us to create more, possibly more or structured meshes. Here's some examples in space-time meshing for some parts. And you can also mix it up, making some parts in space-time meshing, and you can then import those meshes, and then you can build on other parts, other meshes using Workbench, if you like. So you can also mix it. And here's some other examples in creating different meshes, let's say, and also using, if you like, some scriptings for creating meshes. So it's up to you. We are quite flexible here. And as said, it's all about explicit meshing. And we can then export those meshes, if you like, directly for Alice Steiner. So that's the other kind of idea here. Okay, more about meshing. Improvements, as you can see, for difficult situations where you have really thin meshes. Improved error handling. Sometimes we didn't know, okay, where are my problematic areas and what are the elements. So the developers worked on that to improve it for us to find it faster and more reliable. More diagnostic tools like this free mesh edges intersecting elements, body interfacing elements, sharp angle elements. We can now use the worksheet to find them and to visualize them better than before. The same here, the featuring checks, mesh cluster walk. So we can also find mesh clusters and then we can step through it, as we can see in this video above. Then for the explicit, to improve the meshes with better mesh quality or aspect ratio values, so we can directly type them in as the target aspect ratio. And of course, explicit will also help implicit meshes. So use it simply to improve also your implicit meshes. So I think it's a win-win. Thin solids, always a problem in the past, or a challenge. Let's name it a challenge. And we have now new tools like this use proximity gap factor to create finer meshes where needed and keep them coarse on the other areas. Quality checks. You find more quality checks if you like. Feature detection and treatment. So this is something what is really useful. So have a look or play a bit with it. What it means that we can automatically search for fillets or convex surfaces or holes, and then with this kind of found entities in your model, you can directly apply then a certain kind of size for that. So we don't need to find all 50 fillets. We can make it much more focused now. We can have this kind of hex mesh split angles for improved meshes in the multi-zone method. And here's some kind of other control mechanisms to control meshes on some parts, even if you have this kind of assembly. So you can see it's all about quality at that point and what we can now get with this kind of settings. The body fitted Cartesian is quite nice. If you don't use it yet, it creates a kind of hexa mesh. It's bringing a big block around your geometry, and then he's splitting it into some into hexa elements, cutting it off at the boundaries, and then fitting this kind of pure hexa mesh on it. It's much better than the hex dominant mesh. Yep. So give it a shot. Possibly it helps you. If you are not able to make hexas at all, this could be an option here. It's called body fitted Cartesian, and for this one, it was introduced in older versions. There are some improvements in each version. Post-processing, and so we have a lot of speed up to click on name selections, loads, speed up time to hide and show bodies, improve the user interface behavior for thick shells and beams, for instance, speed up time to click on mesh for some models. So it's all about making us wait less time and improving things. Python is another area. I don't know if your version you're actually using can do that. Python is a big thing for Ansys, and it will be. And so it opens up a complete new field of post-processing in the Python environment. You can program your own little scripts. You can paste them. You can also create some customized toolkits, ACTs, and so on. This is a topic in itself. Let me know if you need any kind of information, or you find it on the Learning Hub as well. Enhancements to user annotations and results probe. As a side comment here, then we have accelerated animations. So if you want to run them faster, you find them besides program controlled and standard, you find it accelerated. So there's no video. I thought there is one. And another one is the phase angle display preferences. So if you look at the picture above, some line elements are missing, and having this kind of phase angle display preferences, we could bring this up to 130 degrees and we can get a much better representation of this undeformed model. Composites. I don't know how many people working with composites on your side or with some kind of projects. So composites is always another interesting area, a lot of improvements, and you see import of weld lines are possible now for composites. Is injecting molding data for support unreinforced materials. And this composite prep pose. So as said, it's all about Python scripting, also for composites. And this gives you a complete new possibilities in optimizing your workflows. And at the end, for me, Python scripting is saving times by having one good script and running it for all kind of simulations every time, reliable and fast. And here's some update mode. It's on trigger, so it will run always your script if you like. And here's some example how to parameterize apply coverage and the steps to create a parameter and to bring them in, to create your Python script, and then to use this upper and lower limit into your Python script. And then every time you change your design, this post-processing will be triggering it. And some improvements on the plot visualization, new options to customize all direction plots, scale the vectors, set number of display vectors. So this is one of my favorite topics because I like it that much. It's structural optimization. Structural optimization is about topology optimization, shape optimization, lattice optimization, and in newer versions, topography. And one thing, what it's implemented now, if you want to run it, it's called the HDF5 file. This gives you the direct total deformation and stress values on the design directly after the run is finished. Then we have, besides the von Mises stresses, maximum principal stresses, if you want to use those for optimization, and you can see there are differences, and we can take those into account. We have a user-defined criterion. You can define them under the solution of your static structure, and they are used then as an objective or as a constraint in your structural optimization, if you like. This is the new way to go. What else? So this is a kind of an example for this primary criterion as we name it. You can also combine two primary criterion to a composite criterion, if you like. So we have displacements, for instance, in a remote force constraint, and reaction force to remote displacement, and many other possibilities with this kind of user-defined function. We worked on the modal analysis input, so we have some robust frequency example. This robust frequency example is if we get into some kind of cross modes where two modes are pretty near, and the first mode could get the second mode if we change the geometry, or the optimizer is doing it, and so it will be tracked. So we will know that the first mode will switch to second mode, and this is some kind of an opening idea for having harmonic analysis support in future versions. Linear dynamics, something really interesting. It's called the coupled field static. And this coupled field static you can combine in one block besides structural and thermal, acoustics and electric. So if you have some electric challenges, then you can use this one and directly get your thermal or your structural response based on your input from, let's say, a current and a voltage, for instance. Quite interesting, especially if you want to run it for an acoustics simulation, this coupled field. It was much more complicated with APDL commands in the past. And it's quite straightforward to set, and we can all control this kind of voltage convergence and all kind of entities in this coupled field. There's also a coupled field transient. So check it out and just give me a sign as said for more information if needed. Substructuring generation. This is about having a big structure and then we're using a model analysis just to substitute it. And the substructure generation is then, it's possible, it's working in the GUI. Grab an example, or we have to look up an example and then try it out and see if it works for you, and saves you some computational time. That's always the idea of substructuring. Mode superposition analysis enhancements. This is quite interesting because we can have this kind of on-demand mode shapes, not all you want to get, and you can also, shorten your outputs and save some space at the end. Then we have material damping losses in modal superposition harmonic analysis. There is some improvements here. This will be, I think, really interesting for the course. Then line coatings. So if you need this kind of capability, you can also make a surface coating on a surface. This is just if you have some kind of application where you have used some technical coatings for improving the performance of the parts. So this was also more difficult with APDL commands in the past, possible always, but the surface coating is the big step forward. General axisymmetric enhancements, if you run this kind of simulations. Then also for Maxwell, we have a mechanical coupling now, so we can also include Maxwell in a much easier way into your simulations. Then for the NVH toolkit, we have a MEC calculator, which computes the model assurance criterion between a model analysis and a test file. And this is put into a more comprehensive user interface. And we can then use this kind of mode pairing, what we had before and what we then will have after. So I hope it makes your life easier if you run this kind of simulations. MAPDL contacts. Yes, it's all about having less memory and having faster runtimes. And what you can see is that it's running much faster with this dual shape function than it was with the standard projection of the contacts. And we have a new adaptive smooth sliding options. If you want to apply this sliding, then you can see this standard sliding what we had once for this simulation, 3 hours, and with the adaptive smooth sliding, it runs for 1 hour. So it can be an interesting option for you to speed up and improve your robustness and performance of your contacts here. Of course, it's always a kind of interesting and challenging application which runs 3 hours here. Then again, a lot of this is coming from turbo machinery. This was a challenge to run difficult contacts for large assemblies, and they are done in a 2D environment. And this was not easy, and with this kind of application, a lot of contact robustness improvements were done here. Old pretensions, yes, no video here, is also now supported with general axis symmetric elements. Then we have this mesh independence bolt weld enhancements. So 2 times faster. Then the moment convergence reference calculation. So we have investigated in former versions that we had some kind of not so smooth convergence and some difficulties at some points. And yes, with this new kind of machinery, we are much faster and getting much better convergence. Then MAPDL elements for the PCB boards, we have the binding stiffness for smeared reinforcements improved, as we can see on this slide. And to eliminate the need to use multiple reinforcement layers to capture the bending stiffness. So it was all about simplifying it and make it more usable. And at the moment, many customers are going for chip design, so this was needed at that point. Reinforcements in general, we had it with the concrete in the past, where you have this reinforced concrete elements, but reinforcements are everywhere in PCBs, and with this goes a lot of improvements here for this reinforcements performance. Inverse solving with uniaxial stiffness elements. So it was motivated by the requirements from the biomedical simulations, and those our link and combine elements are now supporting this inverse analysis. Enhancement in robots of coupled field analysis, as shown with the elements, a lot in this regard is needed in the industry, and the development has modified those elements, plane 202 and solid 226. So this solid 226, it's quite an interesting element. You can find a lot of options there to combine all kinds of physics. But in short, if you're using the coupled field module, it will automatically choose this one. Joint element enhancements. And here's some interesting. I thought there is a video in it. No, okay. MAPDL linear dynamics. So just looking at the, okay. Time is running fast. Okay. Multi-stage cyclic symmetry. As said, we had a big project for industry, big industry companies with this kind of turbo machinery applications, and so there's a lot of things, simplifications going into it to run it with less efforts by cyclic symmetry, for instance. A solution comparison using the frequency response functions, RST-MAC. We had improvements for the materials, hyperelasticity with embedded fibers. And as said, to all these sections, you find another 5 to 10 hidden slides, what I don't show, which shows much more in details and sometimes also much more improvements for materials or elements in context. The plastic strain rate dependent isotropic hardening was improved. Hyperelastic parameter fitting with AML, so it's always a challenge, this kind of fitting. Then on the fracture side, we have this stress ratio based fatigue crack closure models. So a lot of things have improved with the fracture. So as said, it's worth if you want to use it for your calculation. Like here, the Paris law, the handling of the meshing for the fractures. So like here, this kind of model where you see the fracture and how the meshing is then built up to show this kind of cracking of the part. Adaptive crack initiation. Nonlinear parts. So this is what happens. This is always challenging and addressed by the development. Always improved, as you can see here in this graphics, the way it is then refining the mesh to meet the requirements of the simulation. Or here with the PCB boards to mesh it where it's needed. For the solver, we have, as said, this resource prediction enhancement. You can find it there, and just to give you an idea. Of course, this direct and iterative solver will be if it's on program controlled, this solver will take over and decide which is the best usage, but we can have a good idea here what it's needed. Then we have this distributed, this hybrid mode. So I know it's a lot to digest at the moment. So just here the kind of idea and let's say to put it into some kind of a chart, we can see the SMP, how it's working, the DMP, the idea of that, and the hybrid. Then a bigger memory can be shared by more nodes or CPUs. Yeah, so that's the idea. It gives some flexibility sometimes for contact areas. If the contact areas are a little bit unbalanced, then we can use the hybrid, can make a good job here. And or we can define it by commands. And we found out that using this kind of technique is heavily improving your runs. Yeah. So we can utilize this kind of technique and improve our performance, the same simulation. So increased performance over time. Workbench additive. It's a lot going on in this area as well. It's worth another hour or two, possibly, in going through all the details. But just to give you a heads up, we have this direct energy deposition. It's a kind of what we have at our desks, possibly with our plastic printers. That's DED, and DED normally in the industry is welding. It's printing. It's printing with metal in a way of a plastic printer, like a DED process. So this is new. We can utilize it here. And then some improvements for heat treatments and all kind of things, what we noticed. Then this kind of additive enhancements to create a smooth transfer to mechanical, to create directly supports in SpaceLame itself if you want, and so on and so forth. So it's a lot of things improved. Explicit dynamics. We have some improvements here. Interesting. I thought it's videos behind that. Multi-material Euler exposed and mechanical for explicit dynamics. Workbench Elistiner. I have another slide set for Elistiner, so I'm just running a bit out of time. We can now import displacements with external data, as you can see here. So it's really the idea to make it much stronger. This Elistiner module and bring over all the important capabilities from Alice Steiner standalone to make it easier for you to get started and to have a better plug and play with the kind of workbench environment. We can use cyclic symmetry. We have a fluent to Alice Steiner one-way thermal transfer if needed. We have restart improvements, enhanced material support, contact scoping is improved. A new server version was plugged into the workbench, so it's not always the latest sometimes, but this version 12.1, and more will follow. I have some really good overview in a minute. I just speed up a bit that we have more time for this time. Time varying acceleration loads we can now use with the RBD solver. A display of joint conditions fittings. And there is another interesting product. It's called Motion. It's a rigid body dynamic solver, which is especially was done for the automotive industry. It has a lot of interesting capabilities, and it's possibly worth to explore in your work. Yeah, that's all I can say at that moment. It's not such a big topic. Just I wanted to make you aware of this kind of new product and this motion. Encode Design Live, our tool for fatigue, and again, enhancements to direct harmonic case with PSD loading as an import. Mostly it's working in a plug and play way, so you can directly plug encode to your static structural solution, and then you can directly run your fatigue if you like. Vibration analysis, and here's some example how it is working. So you have on the left hand side your render selector, your mechanical models, then you have your modal analysis, your static structural, and you can directly set up it from here with the encode embedded live. And the encode itself is a word of itself. You can do a lot of good stuff, not fitting here into a few minutes. Okay, I know it's overwhelming. Now comes the part with a lot of videos and an Alice Steiner overview. Alice Steiner is as big as mechanical, so I really shortened everything as well. Alice Steiner solver is R13. In Workbench at the moment it's 12.1. So possibly you can use the Alice Steiner Workbench, set up your problem in a much faster way, a much more interactive and fun way, and then you can use this model and you can run it also in Alice Steiner R13 possibly. Okay, that's an idea for you. So let's have a look. So meshing as explicit, we had it before. This was one improvement. An improvement was also the mechanical meshing before and after to reduce the small elements, and the feature detection, quality, as we have seen, Alice Steiner updates. So you see on the right hand side the video, what's happening. Unstructured splines, we can run with that. Quite complex things, spot welds, element erosion, advanced plasticity, contact with impactor. Then we have this the T-joints analysis allows more flexibility in conjecturing different patches at T-junctions. To allow the preserve of original angles between patches so that the angle keeps the same. a rigid wall planar, so corrected behavior, spot welds, continuum shells, so added thickness UF with mass scaling, no time step penalty compared to solids, and no significant change in rigid body response. So all about as we have it in implicit to speed up our calculation, having shells instead of solids and saving really elements here. Materials, a ton of materials again, and you can find them into this kind of set. But just to give you some kind of idea, what its new autotropic options for some materials, and it helps for the battery modeling in that sense. Here's some plasticity plus nonlinear viscoelasticity, so more sophisticated kind of models. As we can see, it was not possible without it. Gasket elements, internal vent with chamber definitions, a 3D adaptive mesh for compression molding, then this surface triangulation remeshing, here coupled thermomechanical analysis of 3D orthogonal cutting of steel in automotive applications. So here at that point, we possibly with implicit calculation are not able to do this kind of stuff in this efficient way as we could do it here. Then you see here the analysis of an SPR joining process of a joint strength in automotive application. So the deformations are quite challenging, the joining process, and yeah, we can model that with LS-Dyna. Also, if you have this drilling simulation or the anchor pull out, it's quite an interesting application. What is possible here for this kind of fully implicit ISPG formulation for compressible SPG formulation. I mean, this is things what are not telling me that much coming only from implicit, but people sitting here using LS-Dyna will have a good handle on the kind of naming here. Yep. Particles. And then the X-FAM crack propagation in junction structures. Two-scale co-simulation approach in electronics application. So LS-Dyna has this capability in running a lot of different physics in the same kernel, in the same metrics sometimes. So we can do good interesting investigations in combining it. Contact enhancements for connection methods. Point-wise connections for solid parts. And then this mortar contact feature, which shows really the complexity if we driving through this kind of wall, and then we can see all these particles flying around, and the solver is handling all this frictional energy calculations, interference, and so on and so forth. As stamping processes, you see here this kind of list what has been improved for stamping, and then here's some example for this kind of stamping and the weakening effect of this line bead to make it more real life than we had it before. NVH and fatigue analysis. As you can see, also a lot of interesting improvements here, or new materials in acoustic and boundaries. And this is interesting for these ultrasonic sensors for autonomous driving. So this makes it so valuable at the moment and in the future to have some kind of simulation capabilities to support this kind of simulation for the new field and upcoming technologies. Here another acoustic spectral element method and the kind of reflecting waves we can have and in these models. Modeling resistance spot welding with new load curve options. Then in fluid solid interaction leakage prevention, so that it's really can't escape. Electromagnetic solver. So for magnets, we have addition of magnetic materials, addition of capabilities to simulate permanent magnets, and capabilities to calculate forces coming from magnets. Inductive heating, battery modeling, electrophysiology, and others. And here's some interesting example for this magnet latching. If we can then see how this is then behaving and what is really happening if we having our covers for our laptops or for our tablets, what's happening inside. Electromagnetic brakes and motors, again, really important at the moment for the electrification of the transportation. Inductive heating. Battery improvements. And introduction of electrophysiology models. Honestly, for me, it's something with the heart and the electric impulses, which are doing some muscle contractions, but I'm not firm in this kind of field here. But it's quite interesting what we can do, and it's possible with ELSDyna to simulate the heart, how the commands from the brain getting to the heart to contract and relax, and how the wave from the fluid side is going through the heart, the blood is pumping, and also how the structure of the heart is then deforming and forces acting. So there's a kind of webinar for that. I saw that about 2 years ago. So quite interesting. What is possible with ELSDyna. ICFD incompressible flow solver. As you can see, the meshing was improved, free surfaces, fluid structured interaction, multi-species, and others. And this kind of cannot play media, sorry for that. So it seems the media is not supported here by my, it's booked yesterday, right? Okay, happens, okay. You can get them. Also this free surfaces is also not supported, that's interesting. Then this sled, here you can see the distortion. It's quite interesting if you see the simulation, and it's even more interesting how near it is by the real testing. Of course, it should be matching, that's clear. But it's always astonishing how good it works. And miscellaneous fatigue analysis based on model dynamics. Random vibration. So sorry, all those videos are not playing. No, cannot play. Element material implicit formulations. Also this one then is really bending, is attaching to those heads here and then bending the rest of it. So quite interesting and to see what is possible by simply using an styler. That's it. I'm more or less in time and hope it was interesting and open for questions.
Thank you, Sebastian. Thank you very much. How much time do you still have? Because I know we're at the top of the hour.
Yeah. Okay. What it's needed for me is to tell my manager that I'm coming later. I have a manager meeting now, so let's say I have 5 to 10 minutes left. No problem.
Okay.
Let me just ping my manager.
So I think the best thing is if anyone has very pressing questions, we can take them right now. Otherwise, I can centralize questions for Sebastian afterwards and put you in contact with him. It's true that I forgot to ask everyone to present themselves and what they do, so that we can so that we could also share with Sebastian a little bit the focus of your teaching and research work. And I apologize for that, Sebastian, because I didn't give you a proper setup here. But I think this was very in depth, and this last part with LS Dyna is probably something that I knew less about, and it was really impressive what is possible to do with it. Does anyone have any questions for Sebastian right now? Any comments? Any suggestions? Anything that you would like to relate? No? Okay. So I think we all need to digest the slides a little bit. And in any case, thank you so much for this presentation. I'll definitely follow up with you afterwards if anything arises from our discussions here in Madrid. Where are you now, Sebastian?
I'm in Hanover, in Germany.
Okay, so I hope it's not too cold. Here it's still quite warm. So thank you for taking the time with us today. I'll check in with you very soon, and we'll leave you to your occupations.
No problem. Just the last comment. We will share the slides what are presented here in the full slide sets then later, and we can also collect if someone is interested in improvements from the versions in between what it's now installed, yes, and what was in between. So there's a lot of things and improvements done which are not in the slides that were presented. In any case, if anyone has some specific field and specific interest in some areas of that, simply give us a note, and then we can think about how we can a more focused meeting with those people, and then creating more value that we have more specifics than in the interest of all of that. So that's just a thought to help you to get used to new versions and to see the potential of the update. That's it then. Yeah.
Absolutely. No, this was a great conversation starter, let's say, for here, and lots of food for thought for I think densifying the use of the now centralized licenses that are available here at UPM. So thank you very much. I see that we also have some people online that were following the presentation. I didn't ask, is there anyone online? Does anyone have a question for Sebastian before he leaves?
No, thanks.
Okay. So thank you, Sebastian.
Yeah,
Have
thank
a
you for
great
having me
day.
and for your attention.
Yeah. Talk to you soon.
Yeah, bye.
Bye bye. Bueno, estamos de vuelta acá en Madrid en directo y con los compañeros y compañeras que nos acompañan desde Zoom. Son privilegiados porque normalmente no íbamos a compartir ese enlace. Entonces, no sé, puede ser que yo he dado algunos enlaces, pero hay gente que seguramente ya ha descubierto cosas. Bueno, dentro del programa que teníamos, ahora es el momento del coffee break. Creo que lo necesitamos porque va a ayudar a revigorar y recuperar energías para la secuencia. Entonces, propongo a los asistentes online que vuelvan en unos 15 minutos. Entonces, no sé qué hora es. 11:04, entonces 11:20. Volvemos y seguimos con las charlas. ¿Ok? Hasta pronto.